Good evening. Tonight we turn our attention skyward, to that ever-compelling frontier of space, and to a quiet revolution that is helping us get there. It is not rockets or fuel this time, but something invisible, something thinking. This is a report on artificial intelligence and the essential role it plays in the future of space travel. Hello, I'm Gene Botkin, and today we'll be talking about artificial intelligence and its applications in space travel. Before we dive into code and circuitry, we must first grasp the scale of the problem. Space is not simply far away. It is inhospitable, unrelenting, and indifferent. The distances are unforgiving, and the conditions are extreme. A journey to Mars takes months, and a trip, years. A journey to Mars takes months, and a return trip takes years. And during that span, 1,000 decisions must be made, each with stakes as high as life itself. Now, in the early decades of spaceflight, these decisions were made by people, on Earth mostly, using radio signals to guide astronauts from afar. But time delays in deep space mean that Earth can't always respond fast enough. You may be 12 minutes from help when you've only got 10 seconds. And that's where artificial intelligence enters the story. AI, properly trained and tested, can respond in real time where humans cannot. It can monitor the health of a spacecraft, diagnose problems, and even suggest solutions. It does not need sleep, nor does it panic, and it doesn't even need coffee. And if you're finding this topic as fascinating as we do, then consider subscribing to the channel and liking the video. It helps us continue sharing stories that matter with clarity and care. Automation is the quiet hero of the upcoming space race. Long before AI made headlines, spacecraft were learning to think for themselves. The Apollo missions, for instance, used onboard computers with limited capabilities, and yet even those early systems took over when the moment called for it. The descent of Eagle onto the lunar surface was a human-machine collaboration. The astronaut gave the orders, but the machine kept them alive. And today's spacecraft, like the Mars rovers or the Artemis modules, rely on far more advanced systems. AI-driven automation controls life support, manages fuel use, and balances power systems. In a way, the spacecraft becomes a caretaker, watching its own passengers, correcting its own course, and adjusting to the unexpected in real time. And that is not the purview of science fiction. It is an operational necessity. A manned mission to Mars, or beyond, will need machines capable of recognizing anomalies, making decisions, and even taking independent action when the crew is incapacitated. That is not some dreamy future. It is a contingency plan being worked on right now. And while the headlines often focus on splashy breakthroughs, it is this kind of quiet dependability that defines true progress in spaceflight. Artificial intelligence will not replace astronauts. It will protect them. Artificial intelligence also aids discovery efforts for those who ascend into space. Space exploration is not only about getting there. It is about learning about the environment when we arrive. And the landscapes of other planets are alien in the truest sense of the word. No one has ever been there before, and the terrain is unknown. The conditions shift, and the dangers are unmapped. However, artificial intelligence allows machines to act as scouts. On Mars, for example, the Perseverance rover uses artificial intelligence to choose its own routes. It avoids hazards, studies soil composition, and even decides which rocks are worth a closer look, all without waiting for instructions from Earth. And this autonomy matters. A single command can take minutes to arrive, and in that time, a storm might close in or a wheel might catch on hidden debris. The ability to assess and to respond without human intervention can mean the difference between mission success and an extremely expensive failure. And beyond rovers, artificial intelligence is helping spacecraft analyze atmospheric data, detect geological patterns, and even search for signs of microbial life. This is not a cold calculation. It is the pursuit of knowledge, accelerated. Artificial intelligence helps us understand more, faster, and in places where our senses could never go. And in this way, artificial intelligence becomes more than a tool. It becomes an extension of human curiosity. Our eyes, our ears, and our instincts are all honed by code. However, there is a misconception common in this age of rapid change that artificial intelligence will one day replace the human element. That is a misunderstanding. In space as on Earth, machines serve people, and they extend our capabilities, but they do not replace our values. And the future of space travel will not be cold or mechanical. It will be guided by human judgment and sustained by machine precision. Artificial intelligence systems will support crews in crisis, manage supplies, interpret data, and even offer companionship on long voyages. But it will be human hands that write the mission plans, human hearts that endure the journey, and human minds that choose the destination. The goal is not to let AI take over, but to make space survivable and eventually livable for those bold enough to leave Earth for the beyond. And if you've appreciated this report, then we hope that you'll subscribe. It is a small gesture that helps us continue reporting with clarity and with conviction. And that is the story behind the relationship between artificial intelligence and space exploration. As mankind prepares for longer missions and distant horizons, we carry more than courage. We carry companions made of circuits and of code. And if we do it right, then our companions will bring us home. Thank you for watching. And until next time, this has been a report on artificial intelligence with space travel. Thank you for watching. And until next time, this has been a report on artificial intelligence and space travel. With Elenarda, I'm Gene Botkin. Good night.